Hi everyone. In today's class, we'll see various kind of state diagrams for various kind of flip-flops like JK flip-flop, D flip-flop, and T flip-flop. Right, guys? This is already covered. If you want, you can just go to the earlier video so that wherever I'm trying to explain the JK flip-flop, there itself I have drawn the state diagram for JK flip-flop, and wherever I explained the D flip-flop, there itself I have drawn the state diagram for the D flip-flop. Where I have explained the T flip-flop, there itself I have drawn the state diagram. So this state diagram basically defines how the respective flip-flop is working, right? So means, for example, if I try to write the state diagram for JK flip-flop, if I am present at the 0th state, if I got the J and K values are 0, 1, where it is moving? It is moving to the same state. Similarly, if I am going to present at the 1 state, if I got the J and K as 0, 0, where it is moving, it is going to move to the same state. Similarly, if I am going to have 0, 0 as JK, you are going to move to the same state. So I will try to write directly so that you can get the idea once you go to the earlier videos. Zero, 1 and 1, 1, and this is for 1, 0, 1, 1. This is the corresponding state diagram for JK flip-flop, guys. You can understand it directly, right? Similarly, if you go through the D flip-flop, it is also having the two states. One is 0th state, another one is first state, and on 0 you will move 1, on 0, on 1. This is the corresponding state diagram for the D flip-flop. Guys, I am saying again and again, so go through the earlier videos so that you can get clear idea how to draw this also without remembering anything. Similarly, for T flip-flop, the states are 0 and 1, 0 and 1. On 0 it is 0, on 1 it is moving to first state. From here, if I got 1, I will move to this one state, and if I got 0, I will go to the same state. This is the state diagram for the T flip-flop, guys. Okay, fine. So in addition to this, we will move for further concept, that is Mealy machine and Moore machine. Guys, I don't want to go for in depth about this. This is a kind of basic thing only, which you understood it in the subject of TOC, theory of computation, or in our terminology it is called as a flat. So basically, Mealy machine and Moore machine are works on something and it is going to produce output. How it is going to produce output, that will be defined depending upon the type of machine you are using. So if you take the Moore machine, it is going to produce its outputs depending upon only its current state, meaning that by simply looking its current state, it is going to define its outputs. Whereas coming to Mealy machine, here output values are determined by its current state and current input. This is the difference between Mealy machine and Moore machine. I mean, see, generally, if you look into observation, let us take this is a kind of a state. For example, let me take the state as x. If I am printed the state x, if I got the input as 0, what might be the output is producing? 1. This is what I can call it as Mealy machine, meaning that it is going to consider the current state as well as current input, then only it is going to produce its output, right? If I extend something like this, you can write like this also, right? This is a corresponding Mealy machine. And if you look into Moore machine, if I am presented the state x, if I am got the input, 0, I am going to define its output at the state itself, right? So simply I can call it as on the current state itself I am going to define. For example, if it is moving on the state 1, what might be its output? You can understand this example. This is what you can call it as a Moore machine. But the thing is, you have to mention for all the cases, right? For example, if I say something like this also. Yes. So this is the examples for Mealy machine and Moore machine, right? You have the clear idea in theory of computation, right? So where we are trying to use this Moore machine and Mealy machine in DLD means, in order to represent the behavior of the flip-flops, we can use this Mealy machine and Moore machine, right? Yes. For example, let me try to draw one simple what I can call let me try to draw simple Mealy machine. Like for example, if I say S0, S1 and S2, and if I got the input something like X value as 0, I am going to produce the Y value 0 on this and goes to the S0 only. Similarly, if I got the X value as 1 and I am going to produce the Y value 0, I will move to the S1. Similarly, if I am going to go for X value 1, I produce the output Y equal to 0 and move to the S1 only. Similarly, X value 0, Y value 1, and if I draw like this, X equal to 0, Y equal to 0. If I got X equal to 1, Y equal to 1, move to the same state S0, right? So this is what basically we can call it as a kind of Mealy machine. I mean, you can able to understand, if I give the present state and on the input it will produce its output. Okay? Yes. So can we try to draw its a kind of table for this? Yes, we can represent it, right? So if I am going to represent, for example, the present states might be various kind of s, right? 0 0 0 1 and so on, right? So what might be the inputs? Input always will be X equal to 0 or X equal to 1. I mean, my input is X. You can directly understand. My input is X, and my present states will be either S0, S1 or S2. Assume that S0 is 0 0, S1 is 0 1 and S2 is 1 0. If I assume like this, so if I am trying to consider A, B are the two states combination, so combination is 0 0, 0 1, 1 0, 1 1, 1 1. Okay, so 4 possibilities are there, na? Yes. But if you take into consideration of X value, then you are going to have many cases, right? So 0 0 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. I hope understood, right? So this is what I call it as present state, and this is what I can call it as input. My present states are A, B, and input is X, right? So what is the combination of this entire thing represents? 0 0 defines S0. That is the meaning of this one. If you look into this one, 1 1, 1 1, is there any representation for 1 1? No. For that, how to represent, I will let you know. If you take 1 0, 1 0 defines S2. Like this you have to understand, right? Once you define this one, you can able to expect what might be the next state. That you can understood, right? So means if I am present at S0 on input 0, where I am moving? I am moving to same S0 and my output is Y. That is 0. So I am going to define its Y also. Guys, I am going somewhat fast, so you can understood it easily with your concentration. See, I have the inputs as 0 0, meaning that I am at S0. If I got the input 0, where I am moving? I am moving to S0 only. S0 means what? Again 0 0. Let me call this as A plus and B plus for time being. A plus and B plus. Where I am going to get the output Y? Y is 0 I am getting. Similarly, for 0 0, if I am going to give the value 1, it is moving to S1. What is the value of S1? S1 value is 0 1. And Y value will be again 0. again 0. For 0 1, see, if you have the confusion, just replace S0 with 0 0, S1 with 0 1, S2 with 1 0. Now we can get the clear idea, right? Yes. For 0 1, if I give the input 0, I are going to move to 1 0 and producing the output 1. For 0 1, if I give the input 0, you are going to go for 1 0 and you are producing the output 1. Yes. For 0 1, if you are trying to move, on 1, you are going to go with the same state, that is 0 1 only. 0 1, and it is going to produce output as 0. Similarly, for 1 0, on 0 you are moving for 0 0 and producing output as 0. Similarly, for 1 0, on 1 you are moving for 0 0 again and you are going to produce the output as 1. And what about the states for 1 1? Not mentioned. Not mentioned means you have to take them as don't care, right? So guys, here the point is, you have to follow this particular approach in Mealy machine only. In Mealy machine, if the states are not defined, you have to write them as don't cares. Whereas coming to Moore machine, you should not do like that. You have to just simply leave them as blanks, make them as blanks. Now what you can do, next step, you have to try to construct the circuit, right? So to construct the circuit, you have to solve this particular A plus, solve B plus, solve Y, right? If you are going to solve the A plus, you are going to get A plus as X bar B. Its X is nothing but like not don't care, it is the present input. What about B plus? You are going to get X A bar. What about Y? Y you are going to get as B X bar X A, guys, X A. Okay na? Fine. So once you know the values of A plus, B plus and Y, you can able to draw the circuit diagram now, right? Suppose for example, I am trying to use so let me try to construct it. So inputs are present states, you have to consider present states, and inputs you have to consider. So once you are trying to construct it, so based on, let us assume that I am trying to take the D flip-flops, right? If I take the D flip-flops, this is one kind of a D flip-flop, that is DA, and this is one more kind of flip-flop, that is DB, right? Data flip-flops, right? D means as it is you are going to get, right? Then you are going to produce the states as A and A bar, B and B bar, right? So this is input from the earlier one, right? So here you have to define the A plus, here you have to define the B plus. What is A plus? A plus is X bar B, right? So let me try to take the X value from outside, this will be X. I am going to take the complement X bar, I got X bar. B you have to give the input, right? So B you will get from some other side, guys, you can note down them clearly, X bar B, right? This will be given as this particular side. And what about B plus? B plus you are going to get X A bar, X you are going to get A bar is something like this, something like this, DB. This is B plus. Okay, you got A plus and as well as B plus. But guys, you have to have the control line, right? Control line of these D flip-flops. So we can mention them like this for the clock. Yes, fine. What about Y? So you have to mention finally the output Y also. for the given circuit. So output Y is defined in terms of OR gate. So B X bar plus XA. So XA you have to use compulsory somewhere. So I am trying to use A with AND gate. Good. And here another input might be X. So I will try to take it from this side, XA. And what might be the another input of this OR gate? It is going to be one more AND gate only. It's going to be one more AND gate, that is B X bar. B I can get directly from here. X bar you can take it from its complement. Okay, fine. So this is the corresponding circuit diagram for the given Mealy machine. Okay, I hope understood clearly. Thank you.